All right, well, the South people, you're watching this on YouTube, but, yeah. What?
They're not actually in the class?
No, they have, like, May South has like activities today, and that's just gonna happen today. Normally, they're gonna be over here, but they're trapped over there today. So, normally they will be in class, we're not doing this every day, so. So, there's 6 of you, this year, this is my 32nd year at Mays, and it's a year of extremes. So you guys are the smallest class that I've ever taught, of 6, 32nd, literally, smallest class I've ever taught, okay? My 3rd block, honors physics class, has 30 kids in it. That's the biggest class I've ever taught since I'm in Mays. So I'm gonna go from literally the smallest class I've ever taught to the biggest class I've ever taught. So that's just the hand that we're dealt. So anyway, with all that said, May South, I wish you could be here, but I understand this. So let's kind of talk about classroom policies and the kind of first day stuff. So like I said, this is my 32nd year at Mays, been here for a while. Been teaching in this room alone since 1996. Yeah, it's been a hot minute. So it's AP Physics, which is going to be kind of a cool setting just because there's going to be 6 of you. And I'm excited about that possibility. Like I said, it's just weird that it's the smallest class. Anyway, so here's how I kind of view a setting like this. Let's talk about some classroom policies and all that good stuff. So first off, cell phones, lanyards. It's the elephant in the room. Let's just talk about it. And again, in 32 years, never really had that. They've really come down on this issue. So up there, and my phone is up there in pocket number 1. So once things kind of get sorted out, I'm going to assign you all a number. And like Cohen might have number 5. Will might have number 6. And when you walk in the door, that's where your phones are going to go. And there's only 6 of you, okay? I'm going to notice if your phone isn't up there. So now, here's the reason why. And that's why my phone is up there too. And the reason that, and I've had this policy even before it became like official board policy. And it's because, and you all like to think you can multitask, but you can't. I mean, I'm sorry, you can't. You know, I can have my phone and just have it in my pocket or whatever. So if you look at what takes place for you to learn, okay, it requires a certain amount of effort. It requires a cognitive ability, cognitive effort. So from my perspective, when you look at what I have to do as a teacher, the reason my phone's up there is because teaching at this level, I've got to very much be in the moment. I can't worry about, oh, my phone goes off, oh, what's going on, things like that. That's why I put my phone up there, because I can't have that distraction and do a service to all of you as students, because that's going to go off, or I'm going to have my phone out, and I'm going to look at it like, what's going on? So they did a study, and this is at the Naval Academy. Very competitive group of kids. And they had 2 different classes. It was an economics class. One class, the only thing they had available to them was like paper and pencil. That's it. That's the only thing they could have to take notes. Paper and pencil. No cell phones, no laptops, nothing. The only thing they had was that. The other class, same instructor, same class, everything. They could have laptops to take notes, they could have their cell phones out, everything. Everything was the same, except for the access to technology. Which class had the higher grade average by an entire letter grade? The ones that had the technology. Okay, that's it. And it's like everybody knows that's the answer. And so I can't, I guess morally, have you have your phones, because it's going to be a distraction. And then there's the lanyard issue, okay? So I got mine on, okay? So it's the hand that we're dealt. So, and again, from a teaching perspective in terms of morals, this is the hand that we're dealt. This is board policy says, hey, you guys have to have your lanyards on, okay? And you said, then go, I'll have it on my backpack, or I'll have it in my pocket. So I was discussing this concept with my niece, who works for Coke. And she goes, if you don't have your badge on, that's like a big, and you're on the Coke campus, you don't have your badge on, like visible, basically you will get fired. I mean, that's one of the absolute hard and set rules of industry, more and more because it's a security issue. And so again, morally, if I sit there and go, oh, the rules don't apply to you guys, you're cool kids, which you are, okay, don't get me wrong, you are cool. You're taking AP Physics, okay, y'all are cool, it's not the issue. But if I sit here and go, well, the rules don't apply to you, and then you get out into the real world and you go, well, I didn't have my badge today, it's okay, it was a rule in high school, I didn't have to follow it, and there were no ramifications. Well, then you get out into the real world and you have that same mindset, you're toast, okay? I was talking with an acquaintance of mine, and her boyfriend worked for a big construction company out at, they were doing a job out at, I think, Boeing. And he stupidly put a bumper sticker on one of the boss's cars. I don't know what the bumper sticker was, don't know. He got fired. I mean, just fired, boom, gone, see you, done. So there are consequences to this. So, and again, I'm not gonna ask you guys to do something that I'm not willing to do myself. I'm not gonna sit up and go, oh, I'm gonna have my cell phone out, but I'm gonna expect you guys to put your phones over there. Or I'm never gonna wear my lanyard, but I'm gonna expect you guys to wear yours, okay? So I'm not ever going to ask anything of you.
That didn't take long.
Yeah, I don't know what that was.
That already.
that I'm not going to ask of myself. So, cross the threshold of that door, you have that lanyard on. You walk out that door, you're going to have that lanyard on. Now, we're doing labs and things like that. You want to take that lanyard off, that's fine, okay? So I'm not going to expect you to have it on while we're in class. But
Okay.
on the way in, and on the way out, because it just drives me crazy when I stand out there and see all these kids walk by without their lanyards. That is not going to be my kids. Okay? So when you walk in this door, and when you walk out that door, that lanyard is going to be on. Okay. So let's talk about kind of classroom policies and all that good jazz. So I've got a YouTube channel. Just Google Stan Bergkamp. So that's while we're talking about YouTube. So if you're gone, and I'm going to use the R word, okay, it is your responsibility, yes, the R word is your responsibility, to say, hey, Bergkamp, I mean, hopefully if you know advance, or even if you wake up and you're puking, God forbid, then email me and say, hey, you know, what did I miss, things like that. Most of the time, with the 6 of you, I'm not expecting that to be an issue, but almost all of the stuff that I give you, especially in kind of in that first half, the assignments and things are almost all, I have electronically, and I can just send you that. Some of it, we'll get the books tomorrow. You'll have to check out a book for the class as well. Some of the questions will come from the book, but most of them come from that. I do not have Google Classroom. I hate Google Classroom with every ounce of my being. Thankfully, they've never made me use it. So don't go, oh, look in Google Classroom. You're not going to find it. I don't have Google Classroom. I have the electronic versions of it. I just have my own system. So if you're gone, email me. I'll send you the assignment. I'll have it out on YouTube. You can either, if you just want me to send me the link, email me, or if you just want to go out and find it. So if you go through my YouTube channel, there's a playlist of AP Physics, and so I'll have it sorted. So like if you look on today, it'll say August 15th, like part 1, August 15th, part 2, because typically it's weird, that camera only records like 45 minutes at a time, and then you can't tell it, but it shuts itself off, and then it starts the next segment. So that's why sometimes you'll see like part 1 or part 2. So if you're gone, or and the cool thing about it is if you want to go back and you miss something or you're a little fuzzy on a topic and you can go back and watch it, then you can go back and if you're getting ready for the test, there's that aspect as well. Let me see. And probably this will apply probably to Cohen. If you violate my 2 classroom rules, which are pretty simple, learn what I teach you and don't irritate me in the process, okay? It's pretty simple, but it encompasses a lot. So the next logical question is, gee, Mr. Rokamp, what irritates you? Okay, so if you happen to irritate me, there's 2 ways you can make amends. 1, peanut M&Ms goes a long way. Number 2, the solar project. So if you've seen the solar panels over here at 45th and 119th, there's solar panels on Bay Woodman. That's my baby. So if you happen to irritate me, you can make amends by making a donation to the solar project or peanut M&Ms. Go on, that's probably going to be, you'll probably be the first victim. So
I have no doubts.
I have no doubt in my mind.
I think I've got a lot of. I've got a lot of ones in my wallet actually.
Okay.
So there'll probably be a lot of donations made.
Gotcha.
I have a personal beef with peanut M&Ms.
Really?
Yeah.
Why?
Too
That's
many
a valid
times.
question.
Too many times, I've been eating them, and I'm a really unlucky person just in general. And I'll find bad peanuts in my peanut M&Ms, which then ruins the whole bag because I don't trust them anymore.
Okay, Colin, I have been eating peanut M&Ms much longer than you have ever been on this earth.
Yeah,
I have never found a bad peanut in a bag of peanut M&Ms. Or maybe
Really?
I just don't have a discerning taste. I've
It-
never, literally,
you
it's
can-
never happened to me.
You can tell.
No,
they're-
I guess I don't have a
they're
discerning
bad.
talent.
Cohen, I think you're just special.
I think so. Well, good call, yeah.
I believe it.
Okay, but yeah, literally, I don't know how
I
many of those, one true story, one year for Christmas, I had a class, it was a true story, they took like it was new, but it was a 5-gallon plastic gas can container,
Nice.
filled it with peanut M&Ms. True story. Yeah, it's like they walked in, boom, Merry Christmas, was like, oh, well played, so, yeah.
Little bow on top.
Huh?
Little bow on top.
I don't remember. Yeah, I think they did actually, yeah. But yeah, it was completely full of peanut M&Ms.
Guys will have an idea.
Wow, that's a lot. So,
Let's sell 1,000 peanut M&Ms in gasoline.
what?
Let's soak 1,000 peanut M&Ms in gasoline. Put them on your desk and light them on fire.
Okay, no, bad. Okay,
Sacrifice.
that sacrificing. Okay, I hate plastic water bottles as well. Hope that those irritate me. So if you ever need to, may South people, you can't see this, but you'll see it tomorrow. So if you bring in your, well, has this water container. If you want to refill that, I've got cold water over there. It's chilled, so if you want to fill that, and I will have a glass container over there, throw in some change, something like that. It all goes to the solar fund. So if you need to fill up your water, there's that. It isn't the nasty water that comes out of the faucets at the school. This is just filtered, chilled water. So there's that. So as an
I brought
option.
my water bottle.
I'm just saying. If you really want to get fancy, I've got an ice maker. If you really want ice in the morning, I can fire that up too. So I'm telling you, I take care of my kids. I'm just saying.
Ice?
Cohen is dumbfounded.
That's an ice maker, literally.
No
So-
teacher has ever gone so far for me.
Well, just keep that in mind.
Yeah.
For like, what,
Because, well, here's the reason why.
15 minutes in class?
Huh?
Like 15 minutes into class, far surpassed expectations.
Yeah, that's it. That's all it took right there. Ice maker, perk up, boom, we're in. Okay. All right.
Simple man.
Yeah, I really am. Okay, so on the list of things that irritate me, let's just talk about that while we're here. I don't care if you take notes in pen, you can highlight them, you can write in glitter, I don't care. But anything that you hand in to me has to be done in pencil, okay? And here's the reason why. because I know this is shocking, but you will make mistakes. And then, I know, shocking.
What?
And then you're gonna like blot it all out, and that's going to just irritate me. So, and here's, and this is gonna sound elitist, and I'll admit it, so just don't say, Bergkamp, you're an elitist, yes I am. But here's the fundamental truth. And teachers all know this, but very few will tell you this, but I'm going to. Your job is to make me happy. Fundamentally, that's it. Okay? It is. Because the happier I am, the higher your grade is going to be. Okay? That's it. It's correlation.
Thank goodness we've only got a class of 6. This suddenly became
So
way
yeah, it isn't
easier.
like you guys can get away with anything, because there's only a class of 6. It was like, who did it? I don't know. Like, there's only 6 of you.
Wow.
Yeah.
Danny.
Danny, he did it.
Okay.
Danny
Danny did it.
Yeah, so that would be bad. So, yeah, just don't.
There's no camaraderie.
Yeah, when you hand in papers, if you have like the spiral notebook and there's frizzies on the side of it, make the frizzies go away, okay? Not into frizzies, because then the papers all get stuck together, and it's just annoying. Now, let me kind of play out 2 different scenarios. So, in terms of keeping me happy, and that's a reflection of your grade. So situation number 1, let's say one of you happens to have an older sister that I might have taught, hypothetically. And she hands in her paper, and I'll lay out the format. I want the answers on the left and the work on the right. And it's done very nicely, it's done in pencil, the answers are correct, it's easy for me to grade. My blood pressure stays low, hey, that's gonna get a good grade. Situation number 2, maybe this little brother, who's a nonconformist, hands in the paper with frizzies, done in pen, answers are wrong, I can't track what's going on, my blood pressure goes up, that individual's grade is gonna drop like a rock, okay? So the happier I am, the better your grade's going to be.
Can I propose a third
No.
situation?
Okay, what?
What if the student
To
turns
be
in
named later.
to be named later
A student to be named later.
turns in said poorly done assignment, but also with a cool crisp $5 bill as a donation?
No, no. 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 $100 bill, maybe. $5 with inflation, no. It's not gonna get you there. No, that big a violation would take a Hunsky. Yeah, so,
So what I'm hearing is that for minor violations, I should cover by just putting change on top of my assignments when I put.
no, because that's just gonna irritate me. Dollar bills, maybe, but, yeah, but
Okay, good to know.
I'm
Good
just,
to
I'm
know.
just saying.
No.
Best I can do is $2 bills.
Those are kind of cool, though. I do like
Yeah, those are
$2
kinda
bills.
cool.
Those are cool. I like those. Anyway.
Honestly, I'd rate a 2 over a 5. Like, even though, like, obviously the 5 is worth more, but the $2 bill's coolness factor really just, like, outstrips.
Yeah, but that would be a one-time hit. It's like, okay, I got one. All right, now I'm done.
I don't think I get at least 3. Then you have, like, 1 to show people, 1 to keep, and 1 to use as a bookmark and a cool book. And then you've got all your bases covered.
Okay.
Hey, I got a deal for just for you. A $2 bill for $5.
No.
Ooh.
Yeah. No.
Those bills-
No. That math does not math. Okay. Let me see what else. Those are the big things that irritate me. Let me see. How I'm going to determine your grade. Tests are 60%. This class, and this will apply to you at South people, especially. We don't have a lot of tests in this class, but they tend to take a while to take, okay? So if you're gonna be like a slow test taker, if you want, I mean, you can get it done in the time allotted, okay? You can. But some kids just get hung up and they take forever to take a test. So if you're gonna be one of those people, like the first test, we might get it in before Labor Day, it'll probably happen after that. And this is first block. So if if you think, hey, I want some extra time, you might get here before the start of school to start that test, okay? I'm typically here by about 6:40 every morning. So, and this is also applicable with, like, if you get behind, if you have questions, if you're going, man, Burr Camp, I don't understand acceleration forces, whatever it is. Come in, like I said, I'm here at 6:40, come in, get help. But May South people, because I know you couldn't stay in the second block. So if that's the situation, and you'll know well in advance when I'm gonna give you the test. If you want more time on the tests, you can get here early, start the test then. Homework's 20%, labs are 20%. I grade everything. I'm never gonna give you like a completion grade. I'm never gonna have you exchange papers and grade. Teachers even do that anymore.
No, I haven't had a teacher who has this exchange and grade.
Okay,
Brandon
Alright.
will occasionally have us grade our own stuff, but he doesn't have us exchange them.
okay. That-
And it's normally completion grade work anyway.
Yeah,
So-
so I will never give you a completion grade, I promise you that. I don't have a life outside of school, so I grade everything. So that's why, hey, I want to see it neatly done, all that good stuff. We'll actually start the first lab tomorrow. And obviously there's going to be like only 6 of you, so we'll probably have like a couple groups of 3. Not a big deal there.
Mays versus Mays South.
Huh?
Mays versus Mays South.
Yeah, it might be, yeah.
Whoever has the better
Mavericks
lab
versus
group
Eagles or
wins.
Something like that, so lab final might be an interesting challenge.
Determined at the end of the
Let me see, cell
Duke
phones,
it
we'll
out.
talk about that tomorrow, assign you
semester.
numbers.
There's a scoreboard of that.
Couple of things you're gonna need, you're gonna need a protractor and a ruler, not like, you don't have to have it tomorrow, but put that on your to-have list. We use it a lot when we do like vectors. In the second semester, when we get into optics, we have to draw array diagrams, so just get in the habit of that. We'll get the textbooks checked out tomorrow, so typically an assignment will have some stuff that I give you and then stuff from the book. Once we get into the spring, most of the assignments will just come from the book itself, mainly because in the spring it's optics, it's circuits, it's that are dependent upon like diagrams, and so that way you can just use the diagrams that are in the book. Let me see. Talked about the YouTube channel, talked about water. I think that's about it. Okay, so when you look at physics, so basically what physics tries to do is come up with a way to mathematically describe what is happening in the world. Okay, that's it. That's it. That's not heart and soul of it. So if you look at, if you're a writer, okay, so if you ever read Ernest Hemingway, Hemingway wrote a lot about Africa. After I graduated from K-State, I spent 2.5 years in the Peace Corps in Africa. And Hemingway had this unique ability to capture the essence of what Africa is. So I could read Hemingway, and in my mind, I'm back in Africa, because he understood it, and he had such great words to describe that. If you're an artist, maybe you use sculptures, maybe you use charcoal, maybe you use paints to describe a reality. But physicists use equations. And the cool thing about physics is that there's like 2 different extremes in terms of what physics does. So if you look at biology, okay, hey, biology, you look at the cells, you look at them, you get into organisms. That's about it. And by the way, I know biology is a valid science, it's important, I just don't like biology. It's not my thing. So don't talk biology in here.
Yeah.
I don't want to know about your bodily functions, no, okay? Just say no to anything relating to biology. That's another thing that irritates me.
Oh.
Just don't talk biology. I don't want to know what's going on, I don't care. So, in chemistry, okay, that's kind of reactions of atoms, okay, reactions, that type of thing. Okay, kind of a one-trick pony. It's a cool trick, don't get me wrong, because I also teach chemistry. But physics, though, has two extremes. And what we're going to study is kind of in the middle. So you have one group of physicists who's trying to figure out what's happening on an atomic level, okay? What happens at the structure of the atom. So if you consider, like, if this is, say, a piece of aluminum foil, okay? Say this is a piece of aluminum foil. And you were to stack aluminum atoms side by side by side by side by side, okay? That's about 94,000 atoms of aluminum stacked side by side by side on the thickness of a single piece of aluminum. And then it gets even weirder. So if you consider, like, my hands outstretched on a relative scale to be the size of an atom, the nucleus would be the thickness of a human hair right in the middle. Okay, so here's an atom. The nucleus is the thickness of a human hair in the middle, which means the vast majority of things that make us up, this table, you, everything, is actually empty space. The nucleus contains the protons and neutrons, that's where the mass is located, but space is created by electrons. And so we're just basically mostly empty space. So you have a group of physicists that deal with the very, 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 very small. What is the nucleus made of? Oh, it's protons and neutrons. Well, what are the protons and neutrons made of? Oh, well, let's smash them together, which we'll talk about later. And see what goes flying off there. Oh, there's up quarks and down quarks, all these strange particles. Okay, cool. So then you have the other side of the spectrum of physics that says, let's talk about black holes. Let's talk about the Milky Way galaxy. Let's talk about the universe as a whole and what's happening there. So you have, on the other pendulum side of physics, you have the astronomers who are trying to figure out what's the fate of the universe, what's the mass of a black hole, what's the mass of our sun, what's the fate of the universe, okay? So you have that group which is dealing with the extremely large. So you have one group that says, hey, what's a proton made of? And you have another group that says, hey, what's at the center of the Milky Way galaxy? So where we land is kind of in between. So what we try and figure out is what we call kind of macro scale physics. Not the extremely large, not the extremely small, kind of what happens in the day-to-day life. So basically what physicists is trying to do is said, okay, hey, I'm going to drop this magnet. And if I know how far that magnet falls, I should be able to develop an equation that says this is how long it should take. So Will says, Burkamp, I've got an equation. I'm going to plug some numbers in. I'm going to drop this magnet. I know how far it's going to fall. Will says, this is how long it should take. And then we can time it and see if that number matches what the equation says. And if it does, hey, that's a valid equation. If we drop it and it takes a lot longer, or if it takes a lot less time than it was predicted, our equations aren't valid. So that's fundamentally what physics is trying to do. How can we come up with a mathematical way to describe what is happening in the universe? Now, sometimes it's pretty simple to do. I drop this, it falls, boom, there you go. And even if I take this copper tube, okay, which the magnet isn't attracted to, if I drop this, okay, it falls just like you would think. But if I drop it inside the tube, then it takes a lot longer to fall. If I drop it on the outside, boom, drop it on the inside. So now we're going, what's going on with that? And then you say, well, let's see if we can make some observations. So I'm going to take this is like a special magnetic film. I'm going to wrap it around it, okay? Now when I drop it, so watch that film, and you can see on that film when that magnet passes through. It's like watching an elevator. So what that film allows us to do is that we know, because it's a magnetic film, that if I touch the magnet to it like this, okay, you can see a distortion in that film. But if I just wrap it around the tube like this, nothing happens. But when the magnet passes through there, then something changes. So sometimes we have to go, all right, obviously there's something going on. What can we observe to make that happen? Okay. Now, same thing happens with this. So this is kind of cool. So this is just water with blue food coloring in it. And we can use this to get an idea of atmospheric pressure. Okay, so there's an inverse relationship. As our atmospheric pressure goes up, then this is a higher atmospheric pressure, this column gets pushed higher. If we have a low pressure system come in, then that level's going to drop. So here's the story. So what I'm going to do is that I'm going to wrap my hand around the globe. Okay? I'm going to wrap it around. So what do you think is going to, three things can happen to this level on the outside. I'm going to wrap my hand around it. I will not have any direct contact with the fluid that's inside. Okay? I'm not even going to put my hand and wrap it around the fluid part. I'm just going to put my hand on the glass part that's above it. So three things could happen. Level could go up, level could go down, or my hand has no influence on it whatsoever, and the fluid is just going to stay the same because my hand isn't connected to that system. Okay, so those are the three options. I'm going to put my hand around here. Fluid's going to go up, fluid's going to go down, or it's not going to change at all. Cohen?
I say go up because your hand's going to heat up the air, which will cause it to expand, which will force the water up.
Okay.
I also say it would go up because the heat from your hand will energize the air molecules.
Okay, list of things that annoy me.
Oh.
The word
chemistry.
air molecules.
Yeah, I just came out of chem.
I know, I'm telling you. Look on the periodic table. There is no element for air. Okay?
Yeah.
We got nitrogen, we got oxygen. There is no such thing as an air molecule. And oh, by the way, the word decelerate, forbidden in this room. Do not use it decelerate. I will flip out. Okay? Okay, so back to your story. So the
Wait,
nitrogen and
what are we
oxygen
supposed to
are
say
going
instead
to be
of-
moving,
Faster.
and then what?
It would increase the pressure.
How? What's the mechanism? You say it's going to increase the pressure. What does that mean?
It will, I thought of something, I just lost my train of thoughts.
We'll find that train.
Yeah, give me a second.
Will?
Pretty much the same thing. It will just energize the air particles, making like.
Oh, air particles. Oh, that makes it better.
Yeah.
It's not a molecule, it's a
Not
particle.
A particle.
Particle. Okay.
Particle.
I can maybe kind of gag that one down, but it's a struggle.
What are we supposed to say instead of decelerate?
Accelerate.
But what if something's slowing
Okay,
down?
behind you, no. Behind you, there's a big sign that says F equals ma.
Uh-huh.
And this Newton's second law of motion says force is a product of mass times acceleration.
Yeah.
If you go around the back side, there is not one that says force equals mass times deceleration on the other side of this. Okay?
So
Ah.
even if it's slowing down,
It's so accelerating.
It's-
We'll talk about acceleration later.
It's slowly accelerating.
So acceleration,
It's
it's accelerating towards zero. I don't know, I'm dumb.
okay. So let's just get this straight right now. So acceleration is what we call a vector quantity, which means it has magnitude and it has direction. Okay? So when you're driving your car, you have a certain velocity. Your car is going at a particular speed in a particular direction. Okay? one of the mantras you'll hear me say is that Mother Nature is a lazy prima donna. Mother Nature doesn't like change, okay? If you change something, that requires a force. So let's say you're driving down the road at 40 miles per hour. You need to slow down. What are you going to do?
Break.
You brake. When you hit the brakes, that's going to cause a force, which is going to make your velocity vectors become smaller. Okay? Because if you don't hit the brakes and you're on friction in the surface, your car is just going to keep going because Mother Nature doesn't like change. Okay? So in your brakes, make your velocity vectors get smaller. Okay? Now, you stop, you speed up. What are you going to do?
Hit the gas.
Hit the gas.
Accelerate.
What's the function of the gas pedal?
You accelerate. Makes you go
Do
faster.
what? What's it doing to your velocity vectors?
Increasing it, making them bigger.
Making the velocity vectors get smaller, or excuse me, bigger. Okay? So in both situations, you're changing the velocity vector. Okay? Now, you want to turn. What are you going to do?
Slow down.
No. You're just going to turn. What are you
Oh,
going
we're
to
just
do?
going to turn the wheel.
Turn the wheel. What's going to happen?
Change the direction of the arrow.
You're going to accelerate because now you've changed the direction of that velocity vector.
So,
So-
changing the direction also counts as accelerating.
Yes. Because if you're on a sheet of ice and you turn the steering wheel, what's going to happen?
Nothing.
You're just going to keep going straight. So if you make that velocity vector get bigger, smaller, or change the direction, you accelerate. And that requires a force. So that's why it's always force equals mass times acceleration.
Okay.
And so that's why I'm never going to use the word decelerate, because then it just confuses. It's actually simpler. Now, you could have acceleration that makes your velocity vectors get smaller. That's valid, okay? And that might be, and we'll talk about science and everything like that. And the other thing I'm going to tell you right now, don't think that negative acceleration always means you slow down. You can speed up with negative acceleration as well. But we'll talk more about that later. Okay?
What?
Just don't say the D word. Okay? All right. So you all said that here's the tube, like so. This, we got that fluid. I'm going to put my hand around it.
Ooh, nice hand.
Thanks. And
Impeccable.
I teach physics, not art. Okay? Now, you all say the particles, and how do you even know that there's particles in there?
Because if it was
Can
a
you see
vacuum,
them?
no.
Oh.
But if it was a vacuum, wouldn't the fluid be sucked up into the sphere? And it can be a vacuum. I can see an opening. I guess. I don't know.
But that opening is only on this side. It isn't on that side. Can you see them? Can you see the
No.
little nitrogen and oxygen molecules in there? They don't interact with light. You can't, light passes through them. It doesn't like, hey, it's the table, right? Light's passing through. But let's assume that there are particles in there, okay? Let's assume that there are. And there are, by the way. Now, you all say when I wrap my hand around it, that these little particles inside of here are gonna move faster.
Mm-hmm.
What's gonna make them move faster?
The-
What's the mechanism? And this is what physics gets into. So here's the glass, okay? So there's the glass, here's these little particles. So what's the mechanism that's going to allow those particles to move faster? Because my hand will have no direct contact with those particles inside of there,
The heat from your hand
okay?
will cause them
All right,
KMT.
so what's heat?
Energy.
In what form?
Motion? I don't know. Isn't just the
Well,
particles?
what's the mechanism? That's the
Oh wait,
fundamental-
wait. Heat is
Radiation.
no. That's
Oh yeah, keep going.
Radiation of it.
Rhymes with otons.
photons.
Ah, photons.
Yeah.
What?
Photons. Ooh,
I thought that was like a light thing.
it is.
It is light is radiation.
Yeah.
Oh yeah. This makes sense.
I taught Will Kim one. If he got that wrong, I was going to pummel him with the wooden stick. So,
Can I see the wooden stake?
no,
Oh.
maybe he caught me. I don't know. So here's the story. So then you get into, all right, so the heat from my hand has to go through the glass, right? It has to interact with the particles inside, and somehow or another, these little photons, which you can't see, by the way, is going to interact with particles that you can't see, by the way, which are then going to hit the blue surface, which you can see. But how is that going to make that level go up?
Well, as the air tries to expand, it'll push down on the fluid
How?
because it's colliding more with everything. Because
Okay.
they're moving faster. And because they're moving faster, they exert more force
Okay.
and take up more space.
So now let's talk about what's happening out here. At this interface out here on this side, okay, on that interface out there, what's the dynamic that's happening here? There's two things that are trying to keep this thing down.
Gravity?
Okay? So gravity's trying to keep it down, right?
Yes.
Okay?
Air
Gravity's
pressure?
pulling it down.
Air pressure?
So there's pressure on the outside created by our atmosphere, which is kind of a cool deal that we have an atmosphere. Okay?
Neat.
So gravity's trying to keep it down.
Mm-hmm.
Air pressure on the outside is colliding with it as well, trying to keep it down. So if this happens, and I'm not saying it is, but if it happens, then these particles that you can't see are going to react with photons that you can't see, which is going to collide with the particles here that you can't see, because it isn't like you're going to drop stones in here and you're going to see like waves, right, from water hitting it. And then that is going to transmit that force through the fluid. You can't see, it isn't like a wave moving through it. And then that's going to push this up
Mm-hmm.
against the air pressure that's out here and gravity trying to keep it down.
Yes.
This is what you're all going to say is going to happen.
Sure.
Okay.
Seems reasonable.
Or I'm just a wizard. That's the other option.
Or I feel like, yeah, magic. Black
magic.
magic. Black magic. Because there's no way you
No,
use
it's blue.
light magic.
It's blue magic.
Blue.
So here's the
He's about
story.
to put his hand
So
on
let's assume that it's going to happen. Let's just assume it's going to happen. Will it happen quickly, or am I going to have to hold it for a while to make a noticeable change?
I would say I'd
Probably longer.
take a little bit.
Quantify longer.
A minute.
A minute.
Sure.
So you think I'm going to have to hold my hand here for a minute
Actually,
before
that's-
you see any change in that height?
Any, like,
I would say
how much would you quantify? What would you make? What do you define change?
I
Just
would say,
anything we can
I would
see
say
that's different.
change as being 1 centimeter. So in other words, how long is it going to take for that to change 1 centimeter?
30 seconds.
30 seconds.
5 minutes.
5 minutes.
Yeah.
Will?
I'll go in the middle, about 2.
About 2 minutes.
2 minutes.
Okay? So we got 30 seconds, 5 minutes, 2 minutes.
Oh, your camera can't see your desk.
Okay. Well, I'm going to hold it up.
Okay.
Okay. So for those of you in the studio audience, okay, this is what we got going. So here's this is what we've been talking about. My apologies.
They can see the diagram.
So, all right. So that my bottom hand isn't part of. Can they see this?
No, but I could just move your camera down a little
Yeah.
bit.
Give that a tilt. Okay. So we got 30 seconds, 5 minutes, 2 minutes. Okay.
And this thing does not want to stay.
To change 1 centimeter. Okay. So go up to a height like this. All right. Are we good?
I don't think it's going to want to stay.
Well, you might have to hold it. This one.
I'll just hold it.
Okay, you just hold it. Okay. So somebody got a watch?
Yeah.
Yeah.
Okay, so you start that when I put my hand on here.
Mm-hmm.
Okay, so you ready?
Yeah.
3, 2, 1, go.
Oh,
How long?
3 seconds.
About 3 seconds.
Does that mean I win?
You're the closest, yeah.
Yay.
Okay? So that took about 3 seconds for that to change. So what does that tell you about this process?
It's faster than I thought.
Much faster than thought. Okay? So which means that's a very high rate of change. It isn't like, hey, I got to put this on 5 minutes later. Oh, this is going to be boring. I got to hold this thing for 5 minutes. No, literally like 3 seconds, that changed. So that transfer of thermal energy to make those particles inside of there move faster through an invisible force field, okay? Or the other option is, which is cooler, like working up, you're just a Jedi, and
It's got force powers.
not to brag.
Makes sense.
Well, yeah. So and it's funny though. Somebody had brought up this idea of magic, and if you look at how you define magic, okay, well, magic is something that happens without a logical explanation or something that you can see. So let me postulate this. So I drop this magnet. What happens?
It goes down.
Balls.
It accelerates, right?
Yeah.
Yeah.
Towards the center of the earth.
Mm-hmm.
Okay? And you say, now, when I let go of it, is there any noticeable force acting on the magnet?
Yes. Gravity.
Now, no, noticeable.
Oh.
Noticeable?
That you can see.
No.
No. Just like when I put my hand around here, oh, there's nothing you can see, but yet the fluid goes up. It's magic. Okay? Now, I drop this, and you all don't flip out. Go, gravity. It's not magic, it's just gravity. Now, if I drop this, or let go of it, and it began to accelerate upward,
Lose their mind a little bit.
why? Wells go, whoa, what?
'Cause
So in one
things-
situation, oh, that's gravity. Situation number 2, it's magic. What's the
Because
only difference?
one, we'd
What's the only
expect
difference?
the direction.
The direction of the acceleration. Situation number 1, it's magic. Situation number 2, you're a witch and we're going to burn you at the stake.
Okay.
Okay? No, rude. Okay? But in most situations, if that happened, can you see an observable force acting on the magnet?
No.
No. But in situation number 1, oh, it's just gravity.